Today, we are going to discuss to you or we are going to talk about one of the most important gas law in chemistry, which is the Boyle's law. What is Boyle's law?
Boyle's law was introduced to us by Robert Boyle in the year 1662.
Boyle's law is a gas law which states that the pressure exerted by a gas of a given gas keep at a constant temperature is volume is inversely proportional to the volume occupied by it. In other words, a pressure of a volume of a gas are inversely proportional as the temperature and the quantity of the gas are kept constant.
The simpler term, as the volume of the gas decreases, its pressure increases and the vice versa.
The mathematical expression of Boyle's law is a constant pressure and constant volume, which can be expressed as PV is equals to K, where P here stands for pressure and V stands for volume, where K here stands for constant. This means that for a constant pressure, a constant volume must be maintained. Boyle's law formula was derived into a mathematical formula that calculates the change in volume of different altitude. The formula that calculated the change in volume of different altitude is P sub 1 times V sub 1 is equals to P sub 2 equals V sub 2. Where P sub 1 here stands for initial pressure and V sub 1 stands for initial volume. X equals to P sub 2 is the final pressure and V sub 2 is the final volume. Today's discussion, we are going to solve a problem and explain how to use the formula for Boyle's law. Where are we going to use this formula? Sorry. I'm going to show you a problem and we are going to solve it using the formula of Boyle's law. A gas occupies a volume of 5.0 liters at a pressure of 1.0 atm. What volume will the gas increase to 2.0 atm? By using the Gobson method, we first must identify the given. P1 or P sub 1 or the initial pressure is equals to 1.0 atm 1.0 atm and the initial volume, which is 5.0 liters, and the final pressure or P sub 2 is equals to 2.0 atm, and the unknown, which is the V2 or final volume. Now we collect the given and we're going to distribute the given to this mathematical formula by using the distributive property of algebraic principle and try to solve it. P1 is equals to now we distribute the given to solve for V2. We must first divide this 2.0 atm to cancel out this and for us to leave V2 in the other side. Now we first divide both sides by 2.0 atm. And cancel out the same unit or value. Cancel out V2. ATM, ATM. Now, V2 is equals to 1.0 E. By applying the PEMDAS, we must first solve in here in the parentheses by multiplying the two number, which is 1.0 times 5.0 is equals to 5.0 liters divided by 2.0 is equals to 2.5 liters. Now we got the correct answer. The volume will be 2.5 liters if the gas increased to 2.0 atm. Now, let's try another for us to memorize or to familiarize the equation and the how to solve the problem. We prepared another problem solving just for you to understand it more sincerely and more dramatically. Here is the problem number 2. A gas occupies 10.0 liters at a pressure of 3.0 atm. If the pressure is changed to 1.5 atm, what is the new volume? First, to answer the problem, we must first identify the given. The given are P sub 1 or the initial pressure, which is 10.0 liters, V sub 1, which is the initial volume, which is the 3.0 atm, and the P sub 2 or the final pressure 1.5 atm, and the V2 is the unknown. Now we get the given. Now let's try to solve it by using the formula. The formula is P sub 1 times V sub 1 is equals to P sub 2 times V sub 2. Now, using distributive property or the algebraic principle, we now distribute the given into the formula. Here is now the result of our distribution. To find the V2, we must divide 3.0 atm both sides so we can cancel out these two, only leave the V2 in the other side. Now we identify the given in the formula. Now let's try to solve it by using the distributive property, and let's distribute the given into the formula. The distribution. To get the V2, we must divide both sides by 1.5 to cancel out this 1.5 in the other side. As we divide both sides by 1.5, we must cancel out the same unit and the same value. 10.0 liters times 3.0 divided by 1.5 equals to V2. By following the PEMDAS rule or the process, let's first multiply the 10.0 liters and 3.0. It leads to us by 30.0 liters divided by 1.5 equals to V2. By dividing this, we will get the final volume, which leads to us the answer of V2, or the final volume, is equals to 20 liters. The new volume, if the pressure changed to 1.5, is 20 liters. That's only how you solve the problem, by identifying the given, using the group sum method, and applying the mathematical or the algebraic principle in the science. Now, here are the real-life application of Boyle's law. While inhaling, the lungs are filled with air, therefore they expand. The volume increases, hence the pressure level goes down. Similarly, when the lungs are evacuated of air, they shrink, therefore the volume reduces and the pressure increases. The change in